Hi, welcome. In this video, we'll solve problem GCD implementation using recursion. Now let's check out this problem. Find the greatest common divisor of array. Okay. So given an integer array nums, return the greatest common divisor. Basically, greatest common divisor is the GCD. Okay. For the smallest number and the largest number in nums, the greatest common divisor of two numbers is the largest positive integer that evenly divides both the number. Okay, it evenly divides both the number. So why we are solving this question? Okay, so basically here in this problem, okay, this problem is like a very simple, easy, straightforward problem. But why we are solving? Because we are in this recursion section, and what we want, we need to understand how we can convert a simple iterative code into the recursion. Okay, so the idea behind solving this problem is so that we can make ourselves more familiar with the recursion problems. Okay, so we will just check how we can convert the basic iterative code into the recursion code. Okay, so let's quickly understand the examples. So we have example 1 here. You can see these are the array elements 2 5 9 6 10. So let me put it here 2 5 6 9 10. This is my nums of array, and here also in my nums of array I have 7, then 5, then 6, then 8 and 3. Now from here I need to figure out the smallest element, right? So this is my smallest element. I will say that this is my smallest element, that is 2, and the largest element is 10. Okay, here again the smallest element I have, that is 3, and largest element that I have, that is 8, right? I need to find the greatest common divisor among like these two elements. Okay, so now the problem from the array is converted or bound between these two elements. Okay, so let's see the total factors for 2. What are the factors for 2 we have? Okay, so we have 1 is the factor, 2 is the factor. So basically what are factors? Factors are the numbers that I will say that this is a factor, this number n is a factor of 2 if 2 is divisible by n. Okay, like here you can see 2 is divisible by 1, so that's why 1 is the factor. 2 is divisible by 2, that's why 2 is the factor. But 3, or let's suppose for 3, 2 is not a factor because 3 is not divisible by 2. Okay, so 2 is not the factor of 3. Similarly, let's check out for 10. So for 10, what are the factors available here? So 10 can be divided by 1, 10 can be divided by 2, 10 cannot divide by 3, okay, 10 cannot divide by 4, 10 can be divided by 5, 10 cannot be divided by 6, not 7, not 8, not 9, and only 10. So these are the factors of 10. Okay, now from here, what are the common factors? Okay, so common factors among it is 1 comma 2. Okay, and from 1 comma 2, what is the highest factor? Okay, highest common factor, that is known as HCF. Okay, that is 2, and this is your greatest common divisor, GCD. Similarly here, if I check out the factors of 3, that are 1 and 3. Okay, for 8, that are 1, then 2, then 4, then 8. Okay, so here what is the common greatest divisor? That is 1 only. Okay, okay then. So what are the methods how we can solve this problem? Okay, so if I take two numbers, A and B, okay, one of the approach is basically I need to find out a number, okay, suppose n, which can be divisible by both of them, and n should be the highest. Okay, should be the highest. So we can run a loop, we can check all the possibilities. Okay, so one way is this way. So let's suppose we have two numbers like 12, or let's suppose 24 and 36. Okay, these are the two numbers. Okay, mm, let's suppose A and B, and from here I need to find GCD of it. Okay, so there is one possibility that I can start a loop. Okay, I can start an iteration from 1. I will check, okay, 1 is divisible by both of the numbers. Let's check out for 2. 2 is divisible by both of the number. Let's check out 3. 3 is also divisible by both of the numbers, and so on. Okay, but a bit more smarter way will be, what you can do, you can start from the minimum. Okay, so A and B, first of all, it should be common. Okay, so we can take minimum of A comma B, minimum of A comma B. Okay, like here it is A, and then we can start from A to 1. Okay, so basically we will decrease one by one. Okay, we will decrease one by one, and eventually when we are moving to 1, we will somehow in between get the greatest common divisor, right? So suppose if you, I will take this example, so it will be 24, then 23, then 22, and so on. Somehow you will get 12. That is the greatest common divisor of this problem. Okay, so this is one way to solve this problem. Okay, you can solve it. The time complexity will be around like minimum of A and B. So what are the number, like suppose 24, so it will take 24 steps to complete it. Okay, now let's talk about how we can solve it a bit more in an easy way, or in a bit more smarter way. So the second approach will be that we have solved in our classes. Okay, when we were studying, that is, so we can solve it by the Euclidean algorithm. Okay, so that is Euclidean Euclidean algorithm. Algorithm. Okay, so what is this algorithm? So basically, if you can remember, that suppose you have two numbers A comma B, and let's again take the same example, 24 and 36. Okay, so I will take the higher number here in the dividend, and I will take the divisor 24. Okay, and I will basically divide it. So 24 124, what I will get? I will get 12. Okay, then what I will do, I will make 12 as a divisor, and the divisor will now become dividend. Okay, so it will be 24, and 12 to 24. Okay, I am getting 0 remainder. Okay, and whenever I am getting 0 remainder, the 12 will, the number that was divisor will be your GCD. This will be your GCD. Also you can check, so what are the factors possible for 24? That is 1, again start with 1. So 1, 2, and 3, then we have 4, then not 5, 6, then we have 8, not 7, then 9, no, we don't have, 10, no, 11, no, 12 we have, then 13, 14, 15, 16, so not 16, not 18, then we have only 24. Okay, these are the factors of 24. What are the factors of 36? That 1, 2, 3, okay, 4, then we have 6, okay, then we have not 8 here, okay, because it's 16, it's here 24, it 4 is 32, not 8. Then we have 9 here, okay, not 10, not 11, not 12. Yes, 12 it is, 12 3 is 36, and then not 14, but 16. Yes, 16, 2s are 16, let's check. So not even 16, because 16 to 32, okay, not 36. And then 18 we have, right, 18 to 36, okay. And then in the last we will have 36 only. So these are the factors. Now if I take the common factors, what are the common? So 1, 2, 3, 4, 6, 12, all these are commons right here. 1, 2, 3, 4, 6, 12, all these are common. And here the greatest common, the highest factor is 12. So that's why the HCF will be 12, and that is the GCD of this question. Okay, so yes, you can apply the Euclidean algorithm. Okay, let's check out the same algorithm again with one example. So suppose the two numbers are A and B, and we need to solve. So let's take out two numbers here. So suppose we have 105 and we have 252. Okay, so again, let's see. So 105, I will take this number as divisor. Okay, let me mention it here. I'll take this number as divisor, and I will take this number as dividend. Okay, and let's start. So 252, okay, this number 105 as divisor. Okay, so 105 2, that is 210. What will be the remainder? That is 2 4 42. Okay, now again let's make 105 as dividend now. So 42 2 will become 84, right? So this will become 84, and this will become 21. Now I will make with 42. Okay, then it will 21 to the 42, and it will give me remainder 0. And whenever it is giving me a remainder 0, I will assume that the divisor will be the greatest common divisor, right? So 21 here is the answer of greatest common divisor. Okay, so now let's see how we will solve, how we will create a code for it, how we will create a logic for it. Okay, so if you can see, you have two numbers A and B. Okay, so where A is the divisor, B is the dividend. Okay, so the higher one, okay, always. So here you can see B is greater than A, so higher one will become the dividend. Okay, now again here as well you can see, this will be your A, this will be your B. Okay, here as well, this will be your A, this will be your B. Basically, divisor, dividend, divisor, dividend, divisor, dividend. But if you can think, okay, now your B is A, right? So let me put AB instead of AB. Let me put A1, B1, and A2, B2. Okay, so now you can see B1 is now A, right? 105 is the A, the last A. B2 is your A1. Right, so you can see the same number is coming here, same number is coming here, right? 42. Okay, and what is your A1? Okay, so can I say your A1 will be B modulus A, right? So 252 mod division by A, that I got 42 as a remainder, and that is what my A1. Similarly here, if you can check A2, so A2 is nothing, is the B1 modulus of A1. Okay, so you can see A1 is going to be a B modulus A, A2 is B1 modulus A, and this series will repeat. Okay, and now you can see whenever your B modulus A is equals to 0, you will stop at that condition. Like here you are getting 0, you will stop at this condition, and in this condition whatever your A is will be your answer. So here the A1, what was A2? That was 21. So A will be your GCD here. Okay, so A will be your GCD here. Again, let me explain it again a bit. So B modulus A, okay, we will check B modulus A like here, B modulus A, B modulus A. Okay, whenever my B modulus A is giving me 0, I will say that I need to stop that condition. And at that condition, whatever the A is, whatever the divisor is, will be my answer. Okay, that will be my answer. So let's see how we can create a code for it. Okay, so I will simply take one while loop. Okay, I will take one while loop, and I will say whenever my B modulus A is equals to 0, simply stop it, or I need to stop it. So I will say run a loop if it is not equal to 0. Okay, so you can see B modulus A, when it is not equals to 0, then you can run it. Then you can simply run it. So now let's bring that example here so that we can easily make a code. So let me take a screenshot of this part. Okay, and let me copy and paste it there. Yeah. So now let's see we will check out the things that we have done and we will try to make a code. So whenever b modulus a is not equal to 0, I will simply run a loop. Okay, I will simply run this loop. Okay, and whenever I am getting 0, I will simply return a, because it will come after loop when it is equal to 0. So I will return a, whatever the condition of a will be. And now inside it, I will change this thing, right? So my, what will be my next b? Okay, if I say what will be my next b, so b will be a, right? B will be a. So basically I will store my a somewhere and I will later my b assign my a to b. So here you can see your b1 is the a, here your b2 is the a1. Okay, so I will assign the way. And what will be your next a1? What will be your next a? So my a will become b modulus a. So it will become b modulus a. Okay, now let's quickly understand it. Is it working? How it is working basically? So I will take two numbers, a, that is 105, and b as 252. Again, like here you may think like, why I have not checked if b is greater than a? Because even like if you are starting with a, suppose you are doing 105, then you are doing 252. Okay, even you are starting with this, again you will end up to this situation like how 252 zeros are 252. Okay, what will be the remainder? 105, and then you will take the next divisor as a dividend, and then it will be 252. So again you can see I reached to this position even if I am taking 252 as a divisor. Okay, so in this logic you can take any one of the divisor dividend, but eventually we will come to the same point. Okay, so now let's see. So we have two numbers, a 105, b 252. Okay, so I will assign one temp here. Okay, let's it I am denoting with t. Okay, what will be a? Okay, that, so first of all it is not equal to 0, b modulus a. Let's quickly calculate that first. So let me shrink up this code a bit. So yes, it will become here. And now let's see. So here, what will be my b modulus a? So b modulus a, that is 252 modulus of 105, that will give me 42, right? This will be my remainder. And yes, it is not equal to 0. So I will come here and I will make my temp equals to a. What is a? That is 105. And my new a will become the b modulus a. What is b modulus a? That is 42. Okay. And new b will become the temp. What is temp? That is 105. Now you can see we have reached to this step where a is 42 and b is 105. Okay, again one iteration, again we will come here in this loop. Is b modulus a is equals to 0? Let's quickly calculate b modulus a now. So b modulus a, b is 105 and a is 42. Okay, so if I am taking a modulus of it, I will get 21. So now what will be your temp? Temp will be take your a. What is a? 42. Okay, and a will become b modulus a. What is b modulus a? That is 21, and b will become 10, that is 42. So now you can see we have reached to this step where a is 21, b is 42. Okay, now again next we will check, is b modulus a is equals to 0 or not? So b modulus a, what is b? 42, and what is a? 21. Okay, so 42 modulus 21, that is 0 here. Okay, that is 0. Okay, so I will simply stop it and I will return a. What is my a here? 21. So I will return 21 and that is my answer. So this is how this code is working. Okay, so this is our which code? That is iterative code. Simple I will say this is the iterative code. And now let's see how we can create a recursive code from it. Okay, again we will be needing of both the examples here so that we can create it. So if I do recursively, so basically what is the recursive code, how the recursive code will be. So the best thing to analyze is the code is recursive or not. That can I write a code, can I write a function in such a way that the function call itself with some smaller values, with some smaller inputs. Okay, So basically, can I use the portion of it? Then I can repeat it again and again, and that eventually will give me answer. Okay, is there any smaller part that is repetitive? And here it is. Yeah, you can see we whatever the things that we are doing here, that's a bit of repetitive. Okay, so yes, we can create a recursive code here, and let's see how we can create it. So I will simply write one function. Okay, I will simply write one function. Again, function will take both the terms a and b. So let's suppose take the function name, suppose GCD. I will take, I have a and b. Okay, I have a and b, and if, first of all, a and b, and I will again call the same function. I will again call the same function GCD, but with some different values. Okay, remember, some different value. What are the different value? B is now a and a is b modulus a. Okay, so here we need to put b, a and b. What is a now? A is b modulus a, right? So what I will do, I will add a b modulus a. Okay, and what is b now? B is a, so I will add a here, and yeah, I will return this function. So here you can see we are just changing our a and b in a single step. Okay, now is the base condition when we need to stop. So we will stop whenever my b modulus a is equals to 0. What I will do, I will return a. I will return a. Yes, and that's it. That's the basic function, right? Now you just need to call this function. You will get the answer. Okay, so now let's quickly do a quick dry run of it so that we can understand it. Again, for the dry run, we will add this thing, so we will get some bit of understanding, and I will write the same code, or I can copy it. Okay, so I will copy this one, and let me quickly create one stack, recursion stack. So this will be my recursion stack, and let's take the same example. Let's suppose I am taking GCD of 105 and 210. Will that work? Yes, 105 and 252. Okay, so 105 and 252. Okay, let's take these two terms. Okay, so can I make it a bit more bigger? Yes, so that we will can understand. So now, so we have first call function 105 and 252. 105 and 252. So I call this function 105 and 252. Okay. Now, what is your B modulus A? Let's quickly check. B modulus A, that is 252 modulus 105. What it is? That is 42. Is it equals to 0? No, it is not. Again, call one function. So I will again call one function GCD. Okay. Your A will be now B modulus A. What is B modulus A? This is my B modulus A. Okay. That is 42. So it will be 42. And here your B term will become A. So what was your A? 105. So you will mention 105. Okay, you can see we are at this step now. Now again, after this calling function, again GCD of A and B, again I will check B modulus A. What is B modulus A? So 105 modulus of 42, what it is? That is 21. Okay, is it equal to 0? No. Again one function call. So again I will call one function. Okay, and your A will be B modulus A. What is B modulus A? That is 21. Okay, and your here your B will become A. So your B will become A, that is 42. Okay, again let's execute this function. What is my B modulus A? That is 42 modulus 21. What it is? Okay, that is 0, right? So here I am getting this 0. So I will simply return A. What is A here? What is A here? So in GCD A comma B, A is 21. Okay, so I will return 21. Okay, so this function basically return 21. Okay, it will return 21 and the answer will become 21. Okay, let's quickly see again if I do a recursion tree. Okay, so it will won't take too much time. 104 and 252. This function will call one function. Okay, GCD 42. Okay, same function b modulus a 252 modulus 105, that will become 42, and your b will become a, okay. Now this function again call with one more function GCD, okay, that will be of 21, that is 105 modulus 42, 21 and 42, okay. Now this function will return, okay, this function will return 21 to it, okay, because here 21 modulus like 42 modulus 21 will become 0, so it will return 21, and then this will be returned to this, then this will be returned to this, and eventually you will get answer as 21. So this is how you can convert your iterative code into recursive code, and you will also get some insights like how basically we can transit from a bit of iterative code into recursive code. Okay, so this is how you can simply make it. This is how you can simply solve problems like some all the iterative problems you can solve in recursive way. Okay, so yeah, that's all for today's video. Okay, and we'll see you in the next problem. So there won't be, so here there won't be any code implementation part of it. There won't be any dry run because we have covered all this in one session. Okay, these were the GCDs only. So we have covered everything, and that will be common to all if you are writing in any programming language. So yeah, that's all for today's. Okay, see you in the next problem, a bit more complex problem, and then we will understand how we can move in this recursion unit. Okay, yeah, bye bye.